Yes. Okay, how's it going, guys? Today we're going to wrap these sections up. I know we've been mixing and matching. We're going to go on to 6-6 today. We're going to finish up chapter 6 now. And we're going to talk about function operations. We've talked about functions, but I'm just going to give you a little bit of a reminder, okay? Let's remember that a function is any relation where there can only be one y value, one dependent variable, for any given x value, independent variable. Hopefully by now we thoroughly understand that. Let's talk about some symbols. The symbol f of x, that's read f of x, represents the dependent variable y. F of x and y are the same thing. So in essence, f of x equals y. They're the same thing. The f parentheses x is read f of x. There's no other way to read it. It's f of x, which means, in this particular case, because there's an f here, function f with independent variable x. If I had h of k, function h with independent variable k. G of w, function g with independent variable w. S of t, function s with independent variable t. Okay? That's how we read these. Now, before we get into the lecture of today, let's see if we can go back in time and just remember how to do some simple evaluating. If I said to you, okay, so, excuse me. So, do you remember how to evaluate the following? F of x equals 2x minus 3. The find, no, I meant then find. Okay, if f of x equals 2x minus 3, then find f of negative 2 and f of w. My brothers, what am I replacing the x with in this particular instance? So what do I do to every x I see? Yeah, so that'd be 2 times negative 2 minus 3. So that's going to be negative 4 minus 3, which equals negative 7. Done. Okay? In this second example, what am I replacing the x with, gentlemen? W. So I'm going to replace every x I see in function f with a w. So it's going to be 2w minus 3. Yes, sir. If yes, f of negative 2 does equal negative 7. Because when function f, they replace the independent variable with negative 2, the value of that function f is negative 7. Does that make sense, son? It's a very good question. Thank you. Does this make sense so far, guys? Then this lesson is going to be ridiculously easy. Okay. Now let's take your function skills and tweak them. Let's look at some function operations. Not some. Let's look at the function operations. Okay? Function operations. First of all, addition. If I straight up say to you, f plus g of x, all I'm saying is distribute it, guys. Use the distributive property. This is f of x plus g of x. If I say f minus g of x, distribute f of x minus g of x. If I say f times g of x, that means it's going to be f of x times g of x. And if I say f divided by g of x, it's f of x divided by g of x. Very, very simple. They're basically showing you how to combine functions. Literally. It's that easy. How do I combine functions? Okay. And I'll split screen it. I have some people writing still. But we need to move on. Okay? So, how does this work? Very simple. For example, 1, it says f of x equals 4x plus 5. G of x equals square root of x minus x. I want to find f plus g. Well, if I want to find f plus g, it's going to be f of x, which is 4x plus 5, plus g of x, which is square root of x minus x. Combine like terms and you're done. This would be 3x plus 5 plus square root of x. Done. And actually, standard form should go highest to lowest. Let's rewrite that the correct way. Plus square root of x plus 5. Done. Over. Bye-bye. See you later. Have a good day. I want to find f minus g. Okay? Well, f of x is 4x plus 5 minus g of x, which is in parentheses square root of x minus x. Please go ahead and distribute that negative. So you're going to get 4x plus x, which is going to be a 5x, minus square root of x plus 5 again. And that will be your answer. Pretty simple, right? They're going to give you 2, 3, 4, 5, 6, 7 functions, whatever they give you. They want you to add those functions, and you literally just add the function values together. Literally. Okay? Can I move over to one screen now? Thank you. Yes, sir? Yes, you do simplify when you're done, but here you can't do anything, sir. Because 3x and square root of x and 5, they're not like terms. 5x, square root of x, and 5 are not like terms. And I don't have a 5 in every term of the second of part B. So, okay, does that make sense? Thank you, son. All right, now, let's let f of x equal 3x squared plus 2, and let's let g of x equal x minus 5. Same thing. F plus g. Well, this is going to be 3x squared plus 2, which is f, plus x minus 5, which is g. So this is going to equal 3x squared plus x minus 3. Done. Done. Now I want to do minus f minus g. So, okay, 3x squared plus 2 minus parentheses g, which is x minus 5. So this is going to be 3x squared minus x plus 7. Does that make sense? Pretty simple, right? Okay. Cool beans. Cool beans. All right, next. Now, let f of x equal x squared minus 4 and g of x equal x plus 2. I want f times g. Okay. So I got x squared minus 4 times x plus 2. We know how to FOIL. It's going to be x cubed plus 2x squared minus 4x, but minus 8. And look at that. That's beautiful. Done. Over. Bye-bye. Done. What about if I want to divide those two? Okay. X squared minus 4. Okay, so if I want to divide those two, f of x is x squared minus 4. G of x is x plus 2. Guess what? We've done rational equations. That's why we waited for this, guys. By the way. That's why we waited for all of this. Over x plus 2. Those cancel. So that equals x minus 2. Not bad, right? Okay. It is easy. Good. I'm glad you see it that way. Now, the last part. This is what kills everybody, but because they don't want to pay attention. I know you guys are going to be different. It's called composite functions or composition of functions. When I have a composition of functions, guys, I have a little different symbol. I call it fog because it's not a filled-in multiplication sign. No. It's an open circle sign. So I call it fog or goff. I know it's weird, but that's how I remember it. Okay, fog of x or goff of x. Okay, when you have a composition of f and g, the fog, what this is saying is it's f of g of x. So I have f of g of x. So what the hell does that mean? Yes, sir? Kind of, but no. That means function g, okay, function f, but you're putting the value of function g inside of every x term of function f. You first have to evaluate the inside, then the outside. That's why it says down here, how does it work? Well, if I have fog of x, it's f of g of x. I first evaluate, actually that's wrong. You first evaluate g of x, and then you evaluate f of x. Sorry. Using the value you got in g of x. Now, this is all confusing until you actually do it. Okay? If I have f of x is x minus 5 and g of x is x squared, I want to find GOF. So what I want to find is g of f of negative 4, because that's your x, right? So first things first, guys, what's f of negative 4? Negative 9. So then you have g of negative 9, which is negative 9 squared, which would be 81. Say not that bad. What if I wanted to do fog of negative 2? Fog of negative 2 is f of g of negative 2. What's g of negative 2? No, g of negative 2 is 4. So then you have f of 4, which is going to be 4 minus 5, which will be negative 1. Does that make sense? Yes. Now, just real quick, if I give you just straight up, what if I want f of g of x here? Please pay attention. This is function f, but what am I replacing every x in function f with? No, with g of x. So this would be x squared minus 5, because I took the value of g of x and I plugged it to every x of the f. Does that make sense? That is the lesson, guys. Yeah, that is the lesson. Homework is valid. May God bless you. Have a great day. Hasta la vista. Goodbye.